The Salk Institute, founded by Jonas Salk, who identified and developed the polio vaccine in the early 1960s. The city of San Diego gifted him the beautiful bluff that is the site of the Salk in La Jolla, and to establish his own institute. What he did is he was inspired by what Kahn had done at the Richards Medical Lab in Philadelphia. So he kind of partnered with him, and he wanted to create a space that was inspiring for the science, and that it was the beauty of the land as well as the architecture that brought them together. So in the early 1960s, they kind of teamed up. They came up with a plan. The plan changed quite a bit, but it was a very collaborative design. But from, they went from multiple buildings to one building to two buildings to having a whole housing complex. They really kind of mixed it up and changed quite a bit. But one thing that was constant was going to be the concrete. Kahn was very adamant that he wanted concrete to be the primary element. And really, this was his first project to utilize concrete as the primary architectural component of the building. So the construction, it's all reinforced concrete. And I am a structural engineer, and again, I could go on for hours about the innovations with the structural engineering that's in this building. But the teak and the teak window walls, which Jenny worked on, they're marvels. They're absolutely stunning. The detail, the effort put into these components were fabulous. But it was really the concrete that jumps out and stands out, because it is so prominent throughout the structure. One thing that is fascinating and we were really excited about is when we got on this project is the Salk actually has amazing records of all the construction. They have batch tickets from the trucks. They have all the field reports from the contractor. They have the test reports you could see up there. They have all this, they have meeting minutes from when people were arguing about color and constructability and the width of the fins, and they have all of this. And the kind of takeaway from that was the collaborative design between Kahn, Salk, and the construction team, but the amount of effort with the trials and the mock-ups, and they worked out every detail before they started the production of the building. And so that those two things kind of really jumped out and, very similar to kind of how the repair project took place. I want to take a moment right now, and I would like to pay respect to Paul Matt. Paul Matt was the founder and chairman of Matt Construction up in Los Angeles, but he started his Southern California career as the superintendent for the Salk Institute. Matt recently passed away over the summer. And we all know Kahn, we all know Salk, we all know, kind of those names associated with the building. But Paul, as the superintendent, really lended his voice in the approach and came up with, kind of how they made the formwork. And, those little details that really make the building what it is. And when we had the opportunity to interview him right before Christmas last year, and his memory was amazing, and he remembered all these details about the construction. And one thing that jumped out was the finish on the concrete and the sharpness of the fins and the detail of the form tie holes. They worked through all of that, but it was so complicated with the formwork. They actually built the formwork as if it was cabinets. So they had to find finish carpenters and bring them in. And so they needed something that was cost effective that they could keep reusing, but that would give them the detail and the finish that Kahn and Salk were going after. And so that was kind of his contribution to the design. So I just, they're great designers and they're great owners, but you really need a great contractor to go with you. So in the end, we have this amazing structure. It's complex, it's ornate, it's unique. But the final result is due to that collaborative approach and all the time that they spent doing those mock-ups, doing their research, doing all of their homework before they got out there and started digging. So, how did this project start? Well, the Salk Institute realized they knew they had something special, not only with the architecture community, but also with the science community. And they also needed to figure out a way to take care of this. They needed a path, they needed policies. So with funding from the Getty Conservation Institute, the Salk Institute retained Wisjeni as well as Peter and Skip Architects to develop a conservation management plan. So the conservation management plan, the intention of that is really to help them identify what these critical components are, where they are in what's their condition, as well as develop policies to help them prioritize their approach with their management of this complex. And it's not only the building, so it's not just the walls and the windows, it also dealt with the Travertine Plaza, which is an amazing part of the complex. It also deals with the landscape. So you have hardscape and landscape involved with all of that. So now that they had policies in place, they retained Wisjeni to help them develop repairs for the teak window walls. And then on the heels of that, they also brought us in to help them with the concrete. Not going to say much about the teak, but you can look at these. These are before pictures with the teak. And if you haven't been out there, the teak window project just finished. You can see the success there. And I think the biggest success of that project is we were able to retain 2/3 of the original teak. So it was pretty amazing. So with the concrete, our project, we had several goals. One was we had to understand what was going on, the original materials, as well as the distress. We had to understand what had been done previously to this building, and then we had to stay within the boundaries of both the Secretary of the Interior and NPS Preservation Brief. They really set the gold standard of how to do these projects. So our approach, let's review all these documents that Salk has. Let's interview the people that we can. We did a complete survey of the building to understand the extent of distress. And then we had to develop concrete repairs to match the original concrete, while retaining as much original material as possible. So to do this, it sounds really easy and it's quick to put up on a slide, but it takes a long time. And so we had to come up with a multi-phased approach. Fortunately, with all the other work going on, the Salk Institute was able to give us years to come up with protocols and to develop the concrete repairs, and that's what we needed. We had to be cautious. It had to take time. We had to really look at all the facets of this project, and basically we started with our analysis. We developed some initial mix designs. We did some samples and mock-ups. We did some limited trial repairs, and then we went back to the beginning and did more samples and mock-ups and developed. And it's not unlike the science that's actually happening within the buildings. Their maintenance, or their facilities director, Tim Ball, actually pointed that out in this project. He said, you guys are like experimenting where you figure out what went wrong and then you go back and you adjust it. He's like, that's exactly what they do in the buildings. And he was really excited about that. So the existing conditions, it's right on the ocean. They have concrete, they have rebar. The rebar is going to corrode. Oftentimes they have pretty minimal cover around the rebar, so it doesn't have the protection. So then you get the spalls. They've done some repairs in the past. Not all were successful, both in addressing the distress or matching the concrete. So they kind of stuck out, or they had faded and hadn't lasted the test of time. And so it was really these kind of things that we were trying to address. So we started, we had some samples. We were able to find some samples on site. We did not do any coring, but we found some spalls. And we did petrographic studies, which is where, the petrographer really looks at the concrete in detail, looks at all the material constituents, and is able to identify things. And we were able to really match that to what we thought was the mix design. And the two matched, which was really good. And we had a number on the compressive strength. And so what was fascinating is we'd heard all these stories about how, they were really concerned about the color, and they all, they really worked hard, but all of the materials were local. So where they mined the cement and the local quarries, it's Riverside Cement, it's still open. Of course, the vein in the quarry that they're in is very different, so the color would be very different. The pozzolans that they used actually came from Central Coast. There's now a strip mall there, so couldn't get that. But they had lightweight aggregate that's manufactured in Southern California, Crestlight. So all of this was local, and they did tons of mock-ups and mock-ups and mock-ups. And and they got to where they are. Another anecdote, through this process, I've been fortunate to spend some time with the 3 Kahn children. And Nathaniel Kahn, who lives up in LA, was fascinated by the concrete and the lightweight aggregate and the difference between them. And, you know, he shared a story. He said, you know, my dad was really into picking the right materials to get the right color. Not constructability, that was the contractor's job, but the right color. And so Salk, Dr. Salk, actually gave him a microscope from his lab that he, you know, took back to Pennsylvania, and he would look at all of the constituents underneath this microscope that Dr. Salk had given him. And it just blew my mind imagining Kahn looking at, you know, cement under a microscope from Salk. Was amazing. So where did we start with our mix design? We started with lots of trials, lots of samples. Everything was done off building. I think we ended up with, we thought was we're going to come up with a palette of colors because the color varied. I think we came close to 50 different mix designs. And eventually we came up with a palette of colors that we could compare to the original building. And kind of fit in with all the different elevations and the different colors that are up there. But that was only one component. Then we had to come up with the formwork. We had to come up with the finish. We had to come up with the texture. And, you know, probably the most difficult part of my job is telling a contractor not to make it perfect. We want the variability. We want to see the bug holes. We want, you know, all these things that make it look like the original concrete. We don't want it to be perfect. And so there was a lot of work done off-site, a lot of different things tried, you know, different formwork, different placement approaches, different finishes. But in the end, both the craftsmanship and the experience of the contractor, plus the amount of work that they did ahead of time with all the off-building trials was critical to this project. So the formwork. The original formwork was amazing. You know, it was cabinets. So, but yet there's actually a lot of variability in these fins, which are these guys right here. So we had to come up with a way to match that with our own formwork. So again, we're using modern techniques and materials to match imperfect 1960s materials and techniques. You know, and again, the bug holes, which are all of these, you know, the dark spots. We had to match with our repair. We had to come up with inserts for the form tie holes. We were able to salvage the lead filler that they have, but we had to form our own holes. So trying to get something that was the exact same size and would match perfectly was really important. Then the repair approach, the way it was implemented. So there's components to historic repairs that are very similar to conventional concrete repairs. You have to remove the distressed material. You have to figure out what was causing it. You have to get around the rebar. You have to clean all the corrosion off. You know, you have to do all those things to make durable repairs. We don't want to do repairs that look great that are going to fall off the building in 2 years. So there's a lot of those same techniques. Only you have to be much more careful on a historic building. You can't use 30-pound pneumatic chipping hammers, right? So we're coming in with electric, small hammers. But again, everybody, we mocked this up. We figured out how to do it. They were able to get in there, get behind the bar, clean the bars. We actually ended up using needle scalers because we couldn't sandblast, but we wanted to make sure we got all the corrosion off these bars. You know, to really, again, we had to solve the problem of why they had deterioration to begin with. So that's what we did. We also coated them with a corrosion inhibiting coating. And then, you know, we had our palette of colors and we would decide which one went where before we did the repairs. With the formwork, you know, every repair location, the formwork has to be custom. You have to get the right fin, the right size, but yet the placement technique is still very similar to conventional. You know, you have to get it in there, you have to make sure it's well consolidated. One tricky thing, though, that we ended up having to deal with was the bird's mouth or the spout of how you get the concrete in. And we did all form and pour repairs, which are much more durable than trowel applied. and you know, we had to deal with this spout where the concrete went in, and so that took weeks to figure out, and the contractors had to work that out off the building so that they could figure out the timing and exactly the right tools and exactly how to really get that spout nailed, so that it's, you know, not visible or less visible. But in the end, so on this wall are 2 concrete repairs, and it is a little bright in here, so there's one repair right here, and then there's another repair right here, which has a form tie hole. This has the joint and the fins. And so you can see there's these other locations that didn't get addressed as part of this work. We had to prioritize exactly what we were going to do. And so you know, I guess the lighting makes them look really good. And then here's another wall with some repairs. The repair is actually right here, and this is a close-up of the repair. So right now they did an initial phase of concrete repairs. We have a protocol developed for them, and so they're moving forward. So in conclusion, anything, you know, you have the conventional concrete repairs, but anything that's historic or architectural just makes it that much more difficult. It makes it that much more complicated. And collaboration of the project team, the repair team, the owner, the designer, as well as the contractor is key, but there's also no substitute for the experience and craftsmanship of a contractor. You need that. You need somebody who's worked on buildings like this before. But still, samples and mock-ups are critical. Make sure you have in your schedule time to work on everything off building before you start in on your project. It's critical. You cannot be successful without that. And then make sure that all the expectations are defined before you go into the project. What are the critical components? What are the critical aspects of the work? You know, just have an understanding of that between everybody on the design team, owner, contractor, designer. So moving forward, Salk has, like I said, they just finished the teak window project. They have a CMP, a conservation management plan. And so their next step was they developed they established an architectural endowment fund, which was actually founded with seed money from Jonathan Salk, so Jonas Salk's son, and his wife, Elizabeth Shepard. And then they were able to develop an architectural conservation program, which you may or may not know, but is receiving the CPF President's Award in October. So it's in this picture. So these 3, so we have Nathaniel and then his 2 sisters. Those are the Kahn children. And then this is Tim, who's the facilities director at the Salk Institute, who has, you know, been very critical, or not critical, but he's been critical to this process and instrumental in making sure that all the work is done correctly and for the CMP, and making sure that it's done the way it should be done, so that both the architectural community and the science community are happy with it, and it fits within his budget. So that is it. Yeah, thank you. The contractor, so Rudolph and Slutton, they're throughout California. They have a San Diego branch. They were brought in as the teak window restoration contractor, and then they were able to implement the initial phase of concrete repairs as well. The initial phase, yeah. Yep.
There'll be, we're going to do the questions for all 3 at the end to make sure we have enough time for everybody, but thank you, Ann. Very, very informative. Next up, we have Reuben Lombardo, Reuben with Spectra Company, and Reuben's going to be presenting from the table over here, and we're going to be passing around a lot of samples, not for you to take home, but for you to look at, material samples, and some may be toxic, so don't eat them. But yeah, go ahead, take it away, Reuben.
Okay, I can get the PowerPoint. So thanks for having me today. I'm with Spectra Company. A little, uh-oh. Oh, there we go, there we go. A little information about Spectra Company. We were established in 1985. We work primarily in California. We are hands-on preservation, restoration contractors. So we have almost 150 employees out in the field that are actually working on preservation projects with their hands. They're doing the finishes, the woodwork restoration, the metal restoration, the concrete restoration. If anybody needs a good concrete contractor, like the Salk Institute, if you want to recommend anybody in. I was asked today to talk about aluminum restoration. So aluminum is considered a modern material. And one interesting thing about aluminum restoration, I mean, what do we do when we're looking for a guideline to do restoration? Well, we go to the preservation briefs, right? Is there a preservation brief on aluminum? No, there's not. I know Wayne's going to work on this in the future, but just to give him something to work on. So so what do we do? What are the steps for restoring aluminum? First, I think we need to understand, you know, kind of why we're encountering all this aluminum, and it's curtain wall construction, and with the development of cast iron, the exterior walls of a structure no longer are required to carry the load of the structural components. So, you know, about 1700s, you know, cast iron was developed and it started being used in columns and beams. And so, you know, before the integrity of the building, it was that exterior wall, which was usually, you know, for larger buildings, masonry. Well, now we don't have that. What does that do? That opens up the possibility to having large expanses of natural light come into the building, which is especially helpful before electricity. In 1850, the thing that really spurred the ability to make large pieces of glass was the development of the cast plate glass fabrication. And you know, that can almost be the first project like that was really successful was the Crystal Palace, which is no longer in existence, but this was kind of what led to where we are now with the whole curtain wall industry, and you know, all these big buildings being made with curtain walls. The ability to let all this light in the building, see outside the building, you know, have the inside and outside space to some extent. So when did people start using aluminum in the curtain walls? Well, can anybody tell me what building this is? The Empire State Building. The whole tower of the Empire State Building was actually made out of aluminum. 1931. So again, why don't we have a preservation brief for that? I don't know. But it is still a modern material. And so that was the start of it. You know, the advantage of using it is, of course, it's lightweight, a high-strength material. It's fast to build with. It's sustainable construction material. It's completely recyclable, and even now, you know, up to possibly 75% of all the aluminum that has been made continues to be used. So that it is a green material. It's an amazing material. You know, these are reasons why we shouldn't hate aluminum. This is my plea to you to learn to love aluminum so we can actually restore this aluminum we have. One other thing that attribute aluminum has is it's very resistant to corrosion. But we're going to talk about that later, because as that is an attribute, it has some components to that attribute that cause problems for aluminum structures. And again, we talked about it, the Empire State Building. The entire tower portion was aluminum, as well as, you know, interior and exterior decorative features, entrances, elevator doors, ornamental trim, and 6,000 window spandrels. So fast forward to 1973. This is the Aon Center, and I chose this one because we actually restored the aluminum on the exterior of it. But when we did it, I think it was the second tallest building in all of downtown. Now it's, you know, probably the fourth or fifth tallest. But it's 860 feet tall. And, you know, when we're restoring bronze, we know what we're going after. You know, we know that bronze is, you know, it's going to patina. It's going to have this, you know, effect on it. And because it happens so fast, we're prepared for it. You know, people that are in charge of maintenance of buildings, this is the Beverly Hills City Hall where we, you know, we restored this to this, where we removed the patina from the metal to restore it to its original condition. But because this happens so fast, people can put this in the budget for a project. They know that, hey, you know, every other year we're going to have to remove the patina, you know, on the bronze, depending on what kind of sealer you use. Especially if it's not sealed, then it's going to patina, you know, in a matter of months. So people don't think about that with aluminum. So what happens with aluminum? You know, it's resistant to corrosion, but it can still corrode. This is a picture I actually pulled off the internet of a deteriorated pieces of aluminum, where you can see the pitting, the deterioration of it, the loss of color. So how and why is this happening? Well, aluminum, like any other metal, you know, it's not this impervious material that's going to last forever. It needs treatment and it needs a restoration plan to take care of this material. In the factory, most of the aluminum that we're buying for buildings, it actually comes with a sealer coat on it. And nobody thinks about that because it's factory applied. Well, any kind of sealer that you put on a material, you know, whether it's paint, whether you know it's a penetrating sealer, a surface sealer, it's going to deteriorate over time. So what happens when that deteriorates? Well, then the aluminum starts rusting out. And it is such a modern material that we're just now kind of getting accustomed to this happening. So what do we do? So aluminum restoration procedures. The first thing is we want to, you know, protect the adjacent areas when we start doing treatment on anything. You know, a lot of times it's a curtain wall. We have the aluminum right next to the glass. We want to make sure whatever treatment we're doing to the aluminum, we're not doing to the glass. With the aluminum curtain walls, a lot of times we have sealer to prevent water intrusion. We have caulking. So if we're up there, we're on the building, always a good idea to replace the caulking, you know, as caulking has, you know, a lifespan of from, you know, 5 to 25 years. Then we want to go ahead and clean the surface to remove the surface dirt and contaminants. And then we get to the point where there is that original sealer coating that is on the aluminum. Before we can refinish the deterioration of the aluminum, we need to take off that coating. So we'll use lacquer thinner or a commercial stripper to take that off. And you know, I've worked with WJE before. They're absolutely amazing. That they go through the process of doing mock-ups first and determining what the right procedure is before starting the construction project. And I don't know why that's such a far-fetched idea. But a lot of times it doesn't happen. But you know, once we get that sealer, we got the original aluminum exposed, we want to go through and determine what the right treatment is. And of course, we don't want to be doing this on, you know, the right next to the front entryway, where, you know, if there is some restoration techniques we deem unacceptable, you know, they're going to damage that most visible piece of aluminum. So, you know, we try to find an out of the way area, maybe on the rooftop, that we can actually determine what the right techniques are to use. And what those techniques basically come down to is once we strip that coating, we need to remove the oxidation of the metal. Just like ferrous metal, you know, that starts to rust. just like bronze or copper, which starts to patina. Aluminum does the same thing. So we gotta go back to that original coating that we're trying to preserve and protect. And so sometimes that involves harsh sanding. Sometimes if it's an anodized aluminum, we can polish the surface with very, very mild and light abrasives so that we can actually refinish that original anodized finish. Once that's done, the most important thing is now we have to reapply a sealer so it doesn't patina again. We could, restore an aluminum building, sand it, polish it, get it looking beautiful. And once we've done that, if we don't apply that sealer, it's going to rust again, and it's going to rust faster because it doesn't have any of that original sealer coat on it. Product we use for that is the Everbright Protected Clear Metal Finish. And then one thing to be careful of with aluminum, and I've seen this a lot, we always get called in for water intrusion issues, and with aluminum curtain walls. And there's weep holes set up in the aluminum system, areas where if water gets inside the curtain wall, the water can then come out. Every building engineer, their maintenance dream is to caulk and seal all these weep holes, so that then water, fills up inside the curtain wall and it needs someplace to go out. And usually it's a failing gasket on the interior of the building that the water goes out of, instead of this brand new sealant joint that the building engineers put on. So that's something to always be careful of. So again, mock-ups. These are the mock-up panels we did for the Aon Center. And you can see we got, before and after, and then before and after. These are different treatments here. And these are actually different treatments as well. So it's determining, the how aggressive we need to be. And like anything in preservation, let's start with the gentlest means possible and work our way up till we get to an acceptable end product that everybody's happy with. So here's a scrubbing and sealing. There's our guys on top of the world, 860 feet up. That guy looks a little scared, doesn't he? And so once you start doing this, it's really amazing when you see the transformation it can make, the difference it makes in a building. We have the restored section here, and of course we're starting top to bottom, so when all this gunk runs down, it's not going under our finished work. So are all aluminums created equal? No, there's different grades of aluminums. There's the 1,000 grade, up to the 7,000 grade, and just a ton of different types of aluminums. Just something to think about where you want to make sure that if you are, looking to use aluminum and replacement pieces, you want to get something that has excellent corrosion resistance. And so just why I'm here, a few more little things on modern materials. Concrete restoration. I'm not going to go into the depth that Ann did, but looking at modern materials and what they can be done with concrete. Here we got the Catalina Island Casino, which is a project where we restored the entire exterior facade in Avalon, California, which was I was going to be there fishing every day and looking at the job. It didn't happen, but it was an amazing project. Except, being close to the ocean, the rebar starts to rust, it starts to deteriorate. One thing that we've when we put new cast pieces in, if approved by the structural engineer or it's a non-structural thing, we'll use FRP rebar, which is fiber reinforced polymer. And so if you use that, then you can protect from the rust jacking. Another building we did, the Museum of Man at Balboa Park, we did with Heritage Architecture. And, again, we have this rebar situation with the rust jacking. you know, it's always there. So if we can find a way to get that rebar out. But another modern material that we're using when we do concrete restoration is we'll use silicone molds to recreate the concrete. So here's an example of a silicone mold. And there I have a polymer resin inside, but you could essentially fill it with concrete, and it makes casting a lot easier, a lot more affordable. That, you know, before that, people used to use plaster molds, and you'd have to have multiple pieces because there was no flex to them, and the pieces that you get out would crack and break. So that's a modern material for concrete that's been really great. You know, for the Villa Riviera, how modern materials have helped. This is one where we also did a silicone casting of these gargoyles. They had these gargoyles around the top of the building, and I guess, and probably like the 70s, somebody wanted an unobstructed ocean view, and they ended up taking off some of these cast stone gargoyles. When we went back there, we recreated them. You know, we had to go 150 feet up and, you know, make the molds, and you know, if we had to do this out of plaster 150 feet up, it would be very problematic. But with this, we actually ended up casting these with GFRC. And so with GFRC, you get a lightweight product, so they were easy to move and install. And the GFRC acts as a reinforcement for the concrete. So instead of using the rebar or even the FRP, you're using the glass fibers that are like fiberglass fibers that you mix in with the concrete. So there's a piece of that. That one is actually faux finished to match a terracotta project, but it's using that GFRC. And let's see. So here's the restored images of the gargoyles that we recreated. Here they are at night looking scary. Another thing we did there is the door. Evidently the door was a bronze door. It was donated, you know, to the war effort, was the story we heard. And we had these historic photographs, so we knew there was an amazing door there. Well, we you know, it had all this amazing ornamentation on it. We looked to recreate the door out of bronze, which it originally was. The owners about died with the price tag for that. So they said, what can we do? And so we ended up using a bronze coating over the door, essentially adhesion material with real bronze pigment in it. And so it would actually patina over time, just like a bronze door. And we ended up recreating some of the ornamentation in it. And you can kind of see it right there. And even after we finished, it started even patinaing. And I'll show you some of the pieces that we hand sculpted for this. Those are some of the pieces that we hand sculpted right there on the door. That is cold cast aluminum. And here's the door at night. And here's a picture of the Villa Riviera. Modern materials that I've talked about is, you know, Everbright for aluminum restoration. HilaFix, this is a neat one. This is stainless steel anchors that work on tension to hold pieces in place, whether it's a concrete or terracotta piece. Also, everybody knows about Abbott Ron for woodwork restoration. They also make an Abbott Ron for metal, which is Abbott Ron metal, and for aluminum, especially for aluminum, which is Abbott Ron Metal Fix, which is a really good material for restoring concrete and cast stone, Edison coatings, and cathedral stone. Precision coatings, they do polyurethane coatings for storefront systems, aluminum systems. Sometimes the aluminum is so bad you just have to recoat it, but you can get a coating from them that matches the original anodized finish. And then Zypex, which is actually a foam that you use for waterproofing. So Wayne Donaldson knows a lot about foam, so I will let him talk to you more about this stuff. But just one more thing, you know, keeping connected. California Preservation Foundation, a good way to stay in touch and learn more about how to preserve these materials. APTI and the Association of Preservation Technologies International and the Western chapter of APTI are good areas as well. They focus a little bit more on technical know-how. And AIC, which is the American Institute of Conservation. And please follow Spectra here. And I did bring a few brochures over there and some business cards and a few flyers for WCAPT and APTI. So take a look at those websites, real interesting information.
All right, thank you, Reuben. Okay, and finishing up here is Wayne Donaldson.
Thank you, too. I'm going to go through these slides pretty quickly in the beginning to set you into context so that you can kind of understand where my last two projects I'm going to present, which are the polypods, along with the Ventura House, so that you can kind of understand where they're coming from, and then part of the challenges that we have. Because one of the challenges that we have with a lot of the, at least plastics in this case, are dealing with codes, as well as the structures that are built. Let's see. So let me start off with Richard Neutra. He's a Man of the Year, one of the few architects we have on the Time magazine. It's not like the Time magazines we're getting today. From 1947, but his experimental house that he did starting in 1932 and then a revision in 39 was the Van der Leeuw house, or called the VDL house, the research house. And it was an experiment to deal with many of the new modern materials that was coming in right after the First War. Tragic fire happened that burned down all the way down to the foundations. And in 1963, the reconstruction started with Richard and Diona going off to Austria because they were just fit. They couldn't believe they lost a house. So their son Dion Neutra then started to go ahead and reconstruct it. Aluminum screens, as Reuben was saying, is off to the left and they rotate and stuff. But again, houses to experiment with new materials. Buckminster Fuller, another guy that we have, an engineer and inventor that we have on the stamp. If many of you remember, one of the phases that he started, besides his geodesic dome in his 9-passenger car in the 1930s that would go 100 miles an hour, it only had 3 wheels, so it was sort of defeated by the people that used to make tires at that time. But he coined the word spaceship Earth. And he said, how many energy slaves do you have? That's just robbing electricity. In other words, how many hair dryers, how many electric toothbrushes and all this do you have, so that you can understand. And then he would always, when he would lecture, he would always say to the architects, how much does your building weigh and how much energy did it go into making your building? So he was very conscientious and really started part of the new movements. Now at this time in 1954, in the mid-50s, over 20% of all the housing units that were being made were basically trailers. So people were on the move. The mobility of people to move was very important. Also at the same time that the National Preservation Act came on, in 1966, we had our first issue of Plastic Man, the guy that could form and do things. So now there was kind of a push to getting it to the kids at this time. Rather than your action heroes that you normally had, you had Plastic Man. Didn't last too long. I think it was kind of hard, and I'm going to explain why it was hard for kids to accept. So when we look at plastics, we're dealing with something that's very unique and very different, because we're now dealing with polymer chemistry. And rather than the arrangements of atoms now, all of this comes from organic material. So you could, if you wanted to, put in your will that when you die, you could be cast into a cube of plastic and buried, if you wanted to. Now, most of our stuff, of course, comes from oil. Not only that, but there's a whole new vocabulary that you have to learn when you start talking about the plastics. So this is a molecule of polyethylene, and compare that to your 21 sets of DNA. More complicated, more robust, more difficult to put together, but done by formulation. Each of the plastics that we talk about that have different characteristics are all then tailor-made molecules, which is a lot different than when we're doing with aluminum and stuff like that, even part of our composite metals, because we sort of know how things are going to come out. So the use of polymers, when we're considering and how we're going to select this, we really have to understand what the characteristics are, because it's very difficult to understand what some of the characteristics are unless you know what is the basis for this. Now, some of these you have probably heard about, like polyethylene. I think most of you have seen polyethylene in the wrappers and the bags. Polypropylene, maybe some of you haven't heard of that, but that's what football helmets are made of. They're flexible and strong. And styrene polymers and copolymers. Nylon, of course, was one of the first plastics that come out in the stockings that the women wear, especially. They were keepsakes during World War II. They had to be sewn down the bottom so you had a strip. So a lot of the advertisements then that came out when plastics first came out was to help the housewife save time. And also when cellophane came out, it was unique because before then you had either wax paper and a very crude form of aluminum, so you didn't really know what was in the package. So now you could wrap, not only that, but your triplets. You could wrap your triplets in cellophane so you could really see what happens. Or the Playtex baby pants, which was a lot of the forerunners that we have of the Huggies and stuff now that captured what babies don't want to do. So as we look at the different types of this, and then the reason why I'm racing through this is because there's not a lot of effort to go through each and one of these items by items, but look at the polyester resins, bathtubs and boats. Sometimes you just call it plastics, all right? The thermoplastics, the acrylics, the skylights, the protective enclosures, the urethanes, the foams, adhesives, coatings that Reuben talked about, the phenolic resins, the Formica, particle board. And the Formica and the other groups started off as substitute materials. They look like wood. They look like other products that you would have in a house. Or what then came about for the women, which was really great, was the PermaLift bra, the lift that never lets you down. And this then, remember, in terms of the marketing then, was geared not to the men. This was geared to the women, because when women are buying houses and homes and stuff, it's usually their final decision that has that. So then you could squeeze, you can make stuff of it and everything. And then you had the thermoplastics, and these are the ones that were mostly cast. And we're going to be talking about the applications, the architectural, structural, and non-structural, the weathability, the fire resistant, the color and texture, because all of these materials have to be approved. So I'm going to have David pass these bowls around. Tupperware, for you people that are too young and don't remember Tupperware, you had to burp it before you closed it, which means you had to put the lid on, put a little crack, and then push the air out. So you were sealing it, sort of. You were getting most of the air out, which was just a sales gimmick. You know, you weren't really pulling it all out. But it was the promise of plastics in the 1950s. Now, the bowls that's being passed around here, that David's passed around, this was a thermal bowl. And it was a bowl that came in two parts, was laminated together, and it actually pulled a vacuum so it would keep food hot or cold that's in there. But if you turn that thing over, and this is part of the study that you had to learn, it said, do not immerse. Do not immerse, because if you put it in hot water or something, it could break the seal, and therefore you would never have it. So it was kind of a learn by experimentation. Dacron sort of led to new movements and hang gliding and stuff about the same time. And then plastic surfacings, like Formica and other items like this, which really had tops. And remember, they were substitutes. They were substitutes for other materials initially before they had their own colors. The space program even brought more diversity to it, and most young kids, like our granddaughter up there, wears more plastic than you would imagine. And all of you have plastic, whether it's in your teeth, in bone replacements, in the hair products that you use, the belts, the sandals, the shoes, everything. You have plastics all in you, whether you like it or not, so it's there. And like Reuben, plastics are good. If you remember, the Graduate, where the father-in-law to be came up and told Dustin Hoffman, think plastics. All right, so then we really took off. Other places started making materials that were all plastic, washability, easy to do. You can make different shapes, forms that seemed really pleasant. that, you know, you just want to sit in this chair. It just tells you, sit in my chair. Or when I was doing my studies abroad, I was looking into long span structures, air structures and stuff, and got involved with Frei Otto during the 1972 Munich Games in Stuttgart. So that's where I was focused. Okay, so the buildings, the first National Association of Home Builders said, uh-oh, this plastics doesn't look good for us. So we're going to experiment and we're going to make an all plastic house. Now you can see that that didn't really kind of look like plastic, but that entire house is made out of plastic panels, a Hyperlon roof, and everything. 1957. 1957. So think of that date, 1957. 1957, in Tomorrowland, the Masano House of the Future. Again, not structural plastic, but the structural things were aircraft wings with honeycomb cantilevering out, but everything was coated with plastics. And this really came a draw. This was a draw not only for men and women and housewives and stuff, but the children loved it. It was demolished in 1972, and it was just about the age that I was, and I knew I wanted to become an architect when I saw this. It only stayed up for 15 years, so it didn't stay up too long. It suffered from a lot of bending and everything else, but it was wonderful. A lot of people said, it reminds me of my pill capsule, easy to digest and slide down my throat. Crisp and bright and colors and finishes. It was one of the first houses that really took plastics as plastics rather than as substitute materials. And then it started a phenomenon over everywhere. Osaka, Japan, the Suzuki cabin, 1963, the Netherlands, the capsules. And then to get back to our movement, this stuff about adaptive architecture and people that are moving that became in the 50s, but then grew into the 60s. So when we talk about structural design considerations, these are the things that we need to consider if we're going to use plastics as a primary materials. First of all, the shapes and strengths of it, especially doubly curved or singly curved structures. As you know, an eggshell is extremely strong. I remember seeing a lecture at Palomar College by Buckminster Fuller. He took an 8.5 by 11 piece of paper, he folded into his Tetron things and stood on this 1-inch high cube. So if you know how you're working with your materials, you can make these strong. Plastics in a doubly curved surface like an eggshell is extremely strong. And then other miscellaneous, how you do supports, pneumatic structures, and everything else. So this is one of the projects I had a chance to work at the University of Stuttgart and Frei Otto, again, the Munich Olympic Games in 1972. So now I'm going to talk about two projects. One was a person I went to school with and still friends of, Albert Speidel. He had one more year to finish in his chemistry degree and said, I don't like this, and came over to architecture at Cal Poly San Luis Obispo. And I sat right next to him. And I got infected by him at this time, because remember, I was not really looking at this particular focus in terms of that. So this was a model that he put together. We call them polypods, because polymers, so polypods we thought were cool. And they come in these little pieces here, and you can erect them up and put them together. They're on a small thing, and it postdates the Ventura House. But again, we made the mock-ups out in an old barn outside of Pittsburgh, a place called Confluence next to the National Park Service. And we made these up because we wanted to try to understand what the things were. And Albert just gave me a couple slides where we're kind of have our shirt off and stuff like that, and I'm not going to show that to you. I'm sorry, but that's just not going to happen. So this investor got interested in it, called MHI, and then we decided to go into production. And the production was great. The first one was a bank building, which then later became an optometrist office, and the things were sitting there. And Albert, when I went back to the National Trust for Historic Preservation conference in Pittsburgh, Albert said, go out and see if any of my buildings are left. And I said, okay, and I drove all around. I had the addresses. Everything was gone except for this. And I said, should I tell Albert it's here or not, because I know exactly what he's going to do. He wants to save these and bring them back to California. He did. So he brought them back to California. This is part of the bank. Part of the interiors, very nice. very roomy. So he brought them back, he put them at Cal Poly. They got vandalized, the windows got broken and everything else, and they just sat there and everything else. So he calls me up again and he says, Wayne, can you help me move them once more? And Lori and I went back to Pittsburgh and helped Albert look at them, and sure enough, now they sit out in the field. They're separating where the joints are because of the weather and everything else. Okay, so all these problems that we see with this, unfortunately, and this was in the canyon at Cal Poly, which was experimental. So I got involved in a project, and it was called the Ventura House. It was designed in 1969 by Matti Surinen. And Matti designed these, and it became extremely popular. And we find them all over. He did a big exposition in Finland as a finished product. And I want to point out the 3 windows that come down in the Ventura, this saucer. The bottom 2 windows, as you notice, the floor is right below that. When he initially designed this, it had 300 square feet. It's 11 feet tall and 25 feet in diameter. So it's a pretty small house, but at 300 square feet, that's a really small. That's one of your, what do you call them? Your mini homes or whatever they call them. Your, yeah, those homes, yeah. Okay, so the interior was all plastic, molded in. The beds folded out for the kids. You did have a separate bedroom and all that. Notice the 3rd window that's down below. The kitchen's all plastic. The door's plastic. It was the first to use what you call the living hinge plastic. It did not have ball bearings and stuff. This is a piece of plastic that can be folded several times, and you'll find it on most of your containers now. It's called a living hinge. It's a separate plastic. It was done like eggshells, so you put them all together, or orange slices. You put them all together on this tension ring, and you put them together, but the structure itself is, in fact, structural. Now, during this time, remember, we're in the height of the Vietnam War. They thought, well, gee, we'll just pick these suckers up. You can leave your food in the refrigerator, and we'll just go ahead and move you to your new place and plug you in. So therefore, the mobility of this was a big promotion on the Ventura. Never materialized because most of the helicopters are still in Vietnam. And we found out that it's big. I'm going to tell you a helicopter story in just a second. Now, as I'm looking around and trying to visit all these, there's 6 of them in the United States. There's a lot of them overseas. This is primarily how they all look, with the exception of one in Pensacola. They're not in doing very good shape. In New Taipei City in Taiwan, they have a great collection of them. If you're looking for one, hurry up because they're slowly deteriorating. You can see them there. And they have a very interesting thing that came afterwards by the same company, which is called Polychem, was the Ventura House, V-E-N-T-U, the Ventura House. And you notice that it's more square, more livable, not as round. You notice the window situations. This is part of the promotion catalogs. And they have a lot of Venturas in Taiwan too. So if you want to pick up one and bring it home, be my guest, but it's really deteriorating, especially with the gel coat going. Okay, so Stan Grau got this house and he moved it to San Diego. It was now being manufactured in Pittsburgh. And Pittsburgh used to deliver them in 2 pieces. He had a hard time finding any sales. He could not sell any. He was under license to sell them. He moved them all over the place, and it was a real challenge for him. This is the plan, and all of the furniture was built in, and I must say that the construction is like a bad trailer inside. It's not this really high-class, super plastic stuff, but it's our home and we love it. So, all right, so guess where this was sitting? Down behind the Design Center on 5th Avenue. If you remember, it used to be kind of a local thing. People would have to go down and take a look at it. It's painted in green. The windows have been replaced on it. At that time, we were working on the Naval Training Center. I wanted to save it. I heard they're going to demolish it, so I went to the developer that just bought the Design Center, and I said, I'll take it off your hands. He said, great, I want it out of here right away. And then I get a phone call, and he says, oh, you know, I went online. These are pretty popular. It's now for sale for $25,000. And I said, oh, my God, what have I got myself into? So I said, no, I'll give you 15. So he said, fine, 15, but I want it out of here tomorrow. So I said, well, I didn't even know what I was doing, all right? So we picked it up, we put it on the trailer, we took it out to the Naval Training Center, and at that time, Corky McMillan was just doing the development, and Corky said, get this out of here, we're kicking out residents right now that have been here in shops in order to clear them out. I'm getting a lot of negative press. So I had to pick it out, and I moved it to the San Diego Boat Yard, which is out on Mission Gorge. I don't know what a boat yard is doing way out in Mission Gorge, but there it is. So we started to strip it to find out. We found out the original color was this wonderful yellow, harvest orange, as they called it back then. And the top of it, though, the first 9 feet on there was completely deteriorated. David, you want to pass that around? This is a little heavy. You don't have to take it if you don't want it. But part of the problem is we had a hole up at the top. It had greatly deteriorated, and everything else was deteriorated inside of it. After 2 years on the boat yard, the guy says, I can't have it in the boat. It's not making me any money. Turn it, because I was doing all the work on it. He said, you got to get it out of here. Part of the deteriorations was the separation. When you lose the gel coat, you can see the gel coat on the sample that you're turning around. These are sprayed into a mold, just like your bathtubs and everything else. You'll spray a clear finish in, and then you'll put your color coat, or called your gel coat, in there, just like a Corvette. So imagine taking your 1960s Corvette and just setting it out in the sun, you know, for 20 to 30 years. It doesn't work well. You got to keep it going. So a lot of the repair on this, and I'm going to get to that, we had separation anxiety between pieces. A lot of the bolts were rusted, so we had to come in and put in new stainless steel bolts. They just put in cheapo, good old steel bolts in it. And that's part of the sample that you're being passed around. You'll notice how the gel coat now has left, and you see the fibers. Once the fibers are exposed, the glass fibers, it will transmit water down through the resins, break up the resin. And if you're in a freeze-thaw type of thing, you're going to lose it very carefully. All right, so like we saw with finishing aluminum, this is how you finish if your gel coat is all intact. So you're not doing any fiberglass work, you're not doing any gel coat work. And I also found out as an architect, I had to have special tools that I've never seen before. So I'm going to pass that around. So as you go through this, you'll notice that some of this stuff flare in with Dynaglass, some of the resin feiners, fibers, Duratex, which is another based resin, a vinyl ester. Now, we didn't have a polyester, we had a vinyl ester on this after doing the experiments. And I didn't know why, when I was applying my polyesters, why I was getting bubbles. So this was all learned by doing. I called my chemist friend Albert, and he says, well, that's because you're using the wrong stuff, dude. So as we're going through this, making this all done, you know, the claws, the 90 degree stuff, yada, 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 the number types, just like the aluminum with all the different types. And then finally, after going all the way down this, especially the sterling linear polyurethane, this was a big hassle. You had to get this stuff on within a half hour once you mixed it, because it would freeze in the hoses, and I think I lost about 4 hoses. They're nice stiff hoses because of that when it's set up. Then you apply the all grip, this particular tint, and this is about a 6 paint job. This is the color that you finally see by the time you go with the gel coat intact down to here. All right, then I said, okay, what am I going to do with this thing? Because now I had to move it. And I thought, gee, it would really be great to have a place up at Idlewild, which is at 65,000 feet. It's a mountain range between Palm Springs and Riverside. I didn't know what I was doing. I had no idea what I was doing. So I decided, okay, once I get the property, I went to the county of Riverside to get a building permit, and they said, wow, before you do that, you have to have all of your infrastructure in, your plumbing, your electrical and all that, your foundations there, and then we have to approve your plans. And I said, that's never going to work. So I rolled the dice. I decided to go ahead and package it up and put it on a shrink wrap and move it. And I had to move it as a boat. And I figured, well, since I'm moving it from the San Diego boat yard, let's move it as a boat. Now, I really walked the thing. We drove the thing. We thought we could make it, but you know, Caltrans roads are usually 11 foot wide, and this is 25 foot wide. So along the way, we had to take down a lot of Caltrans signs. I don't know if they ever got elected back up. Some were aluminum, some were wood. We had a guy that was called Jack the Ripper, and he had all these great, what do you call it, chainsaws. So he helped us out as we're going. I think they all got replaced. I also had 3 of my friends that were CHPers, and they led the way, all on motorcycle. And then, since we're doing it in the middle of winter, we got up there, it was almost 37 degrees, I think, 36 degrees. We had a crane that was coming out of Santa Ana as one of these 18-wheelers, these gigantic cranes, because we had to lift it almost 50 to 60 feet in the air. And even though it only weighs 14,000 pounds, to get it up that far, you have this great boom. Where within 5 feet, the guy stopped. And I think he was just mad at me because I said, you're either going to get your butt up here because we dropped all the electrical and telephone lines for the residents up here, so they have no heat if they have electric heat in the middle of winter. So they came up, we're 5 feet short, so we had to grab the legs and swing it into position because he said, I cannot override the computer if I can't see the end of the boom. So we finally got it down, and then we started the restoration, and poor Lori, when she met me, I had this thing, and she's got more Ventura bites on her legs and arms and everything else. But we had all the original stuff in here, all the original furniture. The plastic laminate was still here, the center islands and stuff, the pantries and stuff, and I wanted to restore the interior as faithful as I could without really doing relaminate. So when you go in there, you're going to see a lot of different plastic laminates and stuff. That was difficult. So the first thing was to do the windows. David, you want to hand out that snake there? All right, so since we didn't have the windows, I had a good network, especially with the people in Australia. And one of the guys says, hey, I'll take a window out of my house in Australia and I'll ship it to you so you can see what it looks like. So he shipped it to me. So it had a 3-inch crown and this kind of a bubble eyes. So I took it to a great place near Corona called Planet Plastics. Isn't that cool? So it's called Planet Plastics, and I said, okay, can you form these like you do an acrylic skylight? And they said, no, we're not going to form it that way because if we do an acrylic skylight, you're not going to be able to see out of the windows. They're all going to be warped and wiggly and everything else. So I said, well, how do you do it? And he says, well, here's how we do it. So they capture a square piece. They capture a square piece of acrylic. They hold it into vise. That's the opening right there. And then they go through experiments of heating the acrylic to where it becomes limpy and then blowing it with the pressure air underneath in the cabinet. So it blows up and makes that. So you have to keep experimenting until you get the right temperature and the right pressure and also the right temperature of the air. So then he went ahead and blew these out, and then I had to come up with a concept on how to put these in, and I thought, well, gee, you know, you look at a car, the car is done with this H pattern that we're turning, that you're going around that black snake, 1/4-inch piece of plexiglass here, 1/4-inch piece on a ring that I put around the opening, and it fit right in. And then we had a guy to install it that installs auto glass, because who else can install it better than the guy that installs auto glass? So my contractor got a guy, and he came up and he used it all over. So in terms of care and maintenance, besides just the refit, is you need to make sure that you don't have any kind of spray window cleaner that's in there that says original, because original will contain ammonia. You spray that with ammonia, you have completely destroyed, and you'll spend the next half of your life polishing that out. All right, so you have to make sure you have the right stuff. We're going to pass this around. I had Vincent Marsh. I don't know if you guys know Vincent Marsh. Okay, I'll finish up. Come out. He tried to tighten one of the handles on the piece there, and he broke it off, and he was the most apologetic guy ever. Okay, so 5 little code issues here. One is that the County of Riverside said, I have to put a door in here, because that is not a door. That's a door for a Cessna Citation jet. It's not a door for residents. And it's counterbalanced. It's not too heavy. And I said, well, what do you mean it is a door? And he says, no, no, no. And he sent me this picture. That's a door. He says, that's what I want to have with this little doghouse. And I said, no, 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 no. So he came up, and he actually tried to get out of it. So we saved the door. This just happens to be local residents. So we're able to save the door. We put the bar on there, and it tends to work fine. It's counterbalanced. It probably weighs 160 pounds, but it's about 35 pounds with the counterbalance on a spring. We then had a bad fire during, as I was going through my construction. I had not been signed off, which was the cedar fire. They said, okay, you need to bring a fire truck now within 50 feet of your home. And I said, I can't do that. I'm 100 feet up and by the road, and there's no way. I'm on the big rock. And they said, okay, well, then you got to fire sprinkle it. And so I had to come in and bring the foam. I showed that it was self-extinguishing and all that. So once I fire sprinkled it, then they said I had to get out of I had to have a way to get out of my window, because none of the windows were operable. And again, he sends me a doggone sketch saying, this is what we want you to do so you get out of it. But so we put a drawstring in that little rubber thing in order to get out. So this is a final product. All I had to do is reskin just that center console, and all of the materials in there are there. So this is part of the challenging new design, is the University of Polymers make them the most challenging materials, unlimited in color, texture, strength, and form, if you know how to apply them intelligently. All right, so that's your world of polymers.
And I challenge anyone to find a bigger expert on polymers and Ventura houses than Wayne Donaldson. He's not only knows about them, but is hands-on expertise. So we have a couple minutes. We're going to probably reduce our last break to 5 minutes, and we're going to end at about 4:15. But are there any questions to the panel on our concrete, aluminum, or polymers? Okay, well, there's a question, yeah, here and then in back. Oh, you have the microphone, so go ahead.
I got a question for all three of you. The concrete, I noticed that you pulled that concrete to like a reasonable square you can repair. I'd like you to actually talk about how you make those decisions about how far back and how out to go, or do you always do that, making a repair? Sometimes is it more like a patch?
So the depth, so your question is, how do we determine the depth of removal?
The size of the...
Yeah, so it depends on basically, you know, you have to understand the structure and the materials, but most of the time you have to get out anything that's bad. So you do actually have to remove a little bit of sound material, but you really want to make sure that what you go back with, you're not going to have, you know, too many changes in geometry, because then you end up with a lot of cracking and stuff. So you do want a regular shape, and then you have to make sure that you get behind the rebar.
So from an architectural perspective, it's just make it as small as possible, or were you trying to get to like a line or an edge or something? Okay.
It's sometimes, depending on the type of concrete or the finish, you know, form board, finished concrete where you know, the early stuff where you have the form board, sometimes we'll cheat a little bit and we'll go joint to joint to hide a repair. But like at Salk, where you couldn't hide anything there. It was, okay, you know, make it as small as possible.
Well, I don't want to hog the mic, but I do have another question. For the aluminum, do you have concerns about when you're on aluminum panels about like oil canning and pressing the aluminum when you're doing repairs, or is there a point in that process where you make a decision to pull panels off to repair them somewhere else? Or that to me seemed to be a big challenge with aluminum panels. You know, they have, some of them have more backing than others, some are thicker than others. And can you talk about that a little bit?
Yeah, we always try to leave everything in situ if possible. And the treatments we're doing, they're you know, usually there's not structural treatments on the aluminum. Of course, if you have a structural issue where something's falling off, something's breaking, then you have to remove and reset it.
Okay. So the goal is always if you can.
Yeah. And mostly it's because nobody has the money to remove it and take it off and put it back on.
Got it. Well, thank you. And my last comment was actually more of a comment. I worked at the Design Center for 10 years. I started working there right after that spaceship took off. But people would still drive down that thing, you know, for years. Like, where's the spaceship? Where'd it go? Anyways, and actually I found a little piece of the purple glass that I still have to this day that I kind of kept. It was in the dirt. I found it. It was just a great presentation. Thank you very much.
There was a question up here, was there? Okay.
Hi, Wayne. This question's regarding the Futuro. I was actually wondering what the longevity is for thermoplastics in general.
I think it depends on when they're cast, how they're finished off. For instance, a thermoplastic that you have is the handles that are here, or anything that you find. I think one thing I found is that when they're, and I'm not sure again about the chemical makeup, but for instance, some of the old Bakelite, this is from the 1950s. Its original color was dark brown, and I think that helps. When it got to be clear, like those handles I passed around, or I think it gets brittle. And then it starts to act almost like a crystalline structure, like a glass, that if you get a small crack in it and you start to bend it, it will come. But I'm a firm believer because Lori and I live in a 1959 Carter Sparks house that's built by the String Brothers that has still original plastics in it. And I think it's a matter of maintenance. It's a matter of making sure that you keep it out of the UV because they don't put UV control in there. So I think as long as you do good maintenance, I think it's good. You have to be real careful what you're cleaning it with, though. I found that out.
Would you say that's about 50 years?
I think it's as long as you can make it. Again, it's a polymer, so it's a material that has come together in terms of its chemical basis. In other words, it's the way the atoms are put together. So I think it can last as long as you keep good maintenance. For instance, you know, not many people wax their car once a year. I mean, wax their house once a year. You know, so we wax our thing. So you know, it helps prepare that. Now, the paint that I put on there, which was different because remember now, I don't have a gel coat on the top anymore, all right, or the bottom. The bottom was almost perfect like it was done 15 years ago. Not a problem, because we moved it up in 2004. So we moved it up in 2004, so it's been up there for 13 years. The bottom is perfect, not a problem. But the top, because you're at such a high altitude, a lot of UVs, we had to put elastomers and UVs in the paint. So it's like a boat paint. And it's terribly expensive. It's almost $250 a gallon. So it's really expensive, but it's great once it gets on. But we had to repaint it, what, 2 years ago, I think. I had to repaint the top of it. It's because I don't have the gel coat on there anymore. So now it's just paint. So it's a maintenance with paint. But I think as long as you keep it and you keep the fiberglass and the vinyl resin protected, I don't see why it shouldn't stay there. It does suffer a little bit from creep, structural creep.
And lastly, were you ever able to get it designated on the National Register?
Well, it's funny you should ask me that because when I was having all these code problems with the County of Riverside, I was thinking about designating it so I could use the California Historic Building Code. And I decided, so I wrote the whole application and everything else. I actually had it reviewed by a person, Tony Lee. I don't know if you remember her. She's retired now from the National Park Service. She said it's a great application, and then I decided in the 11th hour not to because I was getting a lot of inquiries from other people, like this one guy that bought the Futural that was a Planet of the Apes ride in New Jersey down at the boardwalk. His name was Matt Damon, not the actor, but he wanted to restore it. So I thought, no, let's restore it and let's deal with the regular code at that time. So I didn't go ahead and get it nominated, but I've had a lot of push to nominate it. But if I did, I think I would nominate it as a multiple property nomination and deal with the other 6 that we have in the United States to do that. I think that would be a good gesture. And the one down in Pensacola is good, and the one up in Michigan is pretty good. The other 3 are like I showed you, sitting out in the field with nothing.
Okay, there's one question online before, and it's essentially a one-answer question. Question was, did the restoration retain the lead plugs at the form connections?
The ones that were there, we kept. And there were, so yeah, actually all the ones we've done, we kept. They've lost some got pulled out for fishing weights, apparently. But especially down low or inside the stairwells, but up high, they were all there, and we kept them.
Okay, well, thank you again to our panel. Okay. We're going to go ahead and you had a final comment?
One little more last thing. You know, what you can do with silicone molds and resins. This is a piece of original historic fabric, which is, you know, hand-carved wood. Well, if we make a mold of it and we recreate it with a resin, it saves us an immense amount of time, and you don't have to have that steel grasp. So we're able to restore things otherwise when we fix. So I'll pass those around.
So no carving required. Those are from a mold. Okay.